So here we're going to talk about the ambiguous case, which is basically the SSA case, or like how I like to say the ass case. So, so the reason why is because it's really annoying. So whenever you have two different sides and an angle, a lot of things can occur. So basically, let me just try to draw a triangle. So let's say you have two sides, you have this angle, and then you have two different sides. Well, sometimes depending on what the side is and what this angle may be, um, if this side is too short and this angle is kind of like little little large, sometimes what can happen is you may have no triangle. So what basically means is that this guy's too short to kind of reach to the bottom of the base. Okay, so that's one of the cases that can occur. Another case, and I like to kind of loop these two guys together. I don't like to think about them as two separate cases, but this case and this case are basically the same, and that's when only one triangle exists. So basically, the side length A is just right. Okay, so they don't necessarily have to be a right triangle. So you can have one that's a right triangle, or you can have one where it doesn't necessarily have to be a right triangle, but there's only one triangle that exists. So that can occur. The other one is when two triangles can occur. So that can actually happen. So, and the way that two triangles can occur is that if I were to have this triangle where you have an angle and a side, then this side can be here, or I can swing this side over. So imagine that I'm swinging this side over to create an angle that looks like this. So I can have a triangle that kind of has an obtuse angle here. So basically this side is being swung to the other side. So depending on the angle measurements and also the other sides, you can have two different triangles. So it really just depends. To solve these two different triangles, that means that you have to do the law of sines multiple times. So that's why I call it the most annoying case. So here there's some directions about when that kind of occurs, and that relates to the altitude h. I don't memorize that at all. All I just do is I just do the problem and see if I'm gonna get a one, no, or two triangles. So basically, here is what you want to be able to do. So let's say you have uh, this type of scenario. So let's say, oh, this shouldn't be an A, this should be a B. Okay. So let's say you have all of these different angles. Okay. So no, you're right. This should be an A. Okay. So let's say big A, little a, and little b are known. Okay, so I know what those guys are. So basically, if you take the sine, so let me give you a triangle. Let me just go ahead and take a look at it. So let's say you have a, you have little a, obviously, and little b. So that means b, big B is over here, here's C, and here's little c. Okay, so let's say I know these two guys. So I'm gonna label them in a different color. So let's say green means that I know what these values are. Okay, so using the law of sines, you can see that I can use sine A over A equals sine B over B. And in this case, what I'm looking for is this angle B, because I don't know what that is. So let's say I go ahead and use that. Now notice I have the SSA case because I have two sides at an angle. So usually if sine B is greater than 1, so when I'm solving that and I get sine B is equal to, I don't know, 1.3, then you have no triangle. And that basically makes sense because the range of b of the sine curve is only between -1 and 1, and 1.3 exceeds that. So even if you forget that, you'll immediately know when you take the sine inverse of 1.3. You'll immediately see that you're going to get a domain error. So once you get a domain error, that you're done. There is no triangle. No triangle can exist. That means that the side of A is way too short to kind of fill this guy in. There's no way that I can figure out an angle that will create this triangle. Okay, so that's the first case. Okay, so now let's say sine of b is a number between 0 and 1, okay, which basically you have a you actually have sine, the inverse actually exists. So what can happen? So that means you can either have one or two triangles. So let's say you sine b equals a value of k, and k is somewhere that within the range. Then you figure out b1 by taking the sine inverse, which basically just makes sense. So b1 is going to be the first triangle. Okay, so one triangle is going to be guaranteed. Okay, so you'll figure out what B is and do the problems normally. Now, if you have a second triangle, this is how you're gonna test it. So if you have a second triangle exists, it may not always exist. What you're gonna do is you're gonna take B2, which is equal to 180 minus B1. So basically, the angle that you just found, you're gonna subtract it from 180. So and then what you're gonna do is take your new B2 and add it to the angle that we know. If it's less than 180, then a second triangle exists. Okay, so this takes a little bit of practice because when you read it, you're like, I don't know what the heck is going on. So, but this is basically what it is. And the reason why we're doing this is because remember that the sine is positive in both quadrant 1 and in quadrant 2. So let's say this is this angle, then that means if there's another angle that exists that's obtuse, okay, then all we got to do is just subtract it from 180 to figure out what that angle may be. Okay, so that's the whole purpose of it. So as long as you follow these directions, you should be pretty good and pretty solid. So hopefully, let's just pray to the law of science gods that you just get no triangle and then you'll be done. But then you might have to do a little bit more work if you have one of these, especially if you got 2b as a case. All right, so let's start off with the first problem. So suppose A equals 17.9 centimeters, B equals 13.2 centimeters, and big B is equal to 75.3 degrees. So determine if 1, 2, or no triangles exist. Okay, so let's first start off by drawing a triangle, because this time they didn't give us a demo. So, so I know B, let's say this is B, this guy is 75.3 degrees. So then little b must be opposite of it, which is 13.2 centimeters. Let's just say this is A. A is going to be 17.9 centimeters, which basically means that this is big A, this is big C, and this is little c. Okay, so the first thing that we're going to do is let's try to use the law of sines, because, and notice that you have the angle side case. So you basically have this weird case. So let's go ahead and start. So you're going to have sine B over little b equals sine A over little a. Okay, and let's go ahead and solve. Now, one of the things to just kind of keep in mind before we continue the problem is that I just chose an arbitrary value, so it doesn't have to be a, and little b. I could have, and this guy big B, it can be any letters. I just picked those letters for this example. Okay, so we have sine B. So you have sine of 75.3. Okay. And then you have divided by b, which is going to be 13.2, is equal to sine A. So this sine A, I don't know what that is, divided by little a, which is 17.9. Okay. So now what we're going to do is cross multiply. So we're going to get 13.2 sine A equals 17.9 sine of 75.3. Okay, and then we're going to divide by 13.2. So we're going to get sine A is equal to 17.9 sine of 75.3 divided by 13.2. Okay, so let me put that into the calculator. So you're going to have 17.9 sine of 75.3 divided by 13.2. And what you're going to get is 1.31. So already you can stop there because you can see here that this exceeds 1. So you already see that there's going to be no triangle. But let's go ahead and just take it further. Let's go ahead and take sine inverse of this. And when you put that in your calculator, you're going to get a domain error. which basically means that you are exceeding. There's no way that their triangle can exist. So in this one, no triangle exists. Okay, so then you stop and you're done. Okay, so just like that. So you don't have to continue on. All right, so now let's do this next example. So suppose that you have these measurements. Okay, it seems like you have another angle side case. Determine if 1, 2, or no triangles exist. Okay. So how do we do this? So let's start off by doing the same thing that we did before. So here is B. This is going to be 68.7 degrees. So then that means little b is going to be opposite of that, which is going to be 25.4 inches. Then you have little a. Let's just make this little a. 19.6 inches. So then big A is going to be here, big C is here, and little c is right there. Okay, so we're going to do the same thing, use the law of sines. So I'm going to have the sine of 68.7 divided by little b, which is going to be 25.4, is equal to the sine of A divided by 19.6. So let's cross multiply. So you're going to get 19.6. The sine of 68.7 is equal to 25.4, the sine of A. And let's divide by 25.4. So we got that the sine of A is going to be equal to, so let's put this in our calculator. So 19.6 sine of 68.7 divided by 25.4. And I end up getting 0.7189, something like that. Okay, so notice that here a triangle will exist. So one triangle at least is guaranteed. So let's take the sine inverse of this number and let's figure out what this measurement is. So A is going to be approximately sine inverse of this guy, and I got about 45.9 or about 46 degrees. Okay, so if I round it to the nearest degree. Okay, so this actually is your first angle, angle 1. Okay, so now you kind of have to ask yourself, does a second triangle exist? Okay, so let's just ask ourselves, does a second triangle exist? Okay, so let's think about that. So the only way that we know a triangle exists, so let's go back up. So let's see what we had to do. So a second triangle will exist. So let's look at this. So what you're going to do first is you're going to figure out B2, or your second angle, is to subtract 180 minus B1. Okay, so I'm going to take 180. So let's see. So I'm going to take, so your A2 is going to be if I take 180 minus your A1 that you just figured out. So I'm going to take 180 minus 46. Okay, so I'm going to do that. 180 minus 46, that gives me 134 degrees. Okay, now let me see. So now what we got to do is that we're going to add this guy, this new A2, to our original angle that we are given, which is going to be the 68.7 degrees. Okay, so we're going to take this 134, add it to 68.7. Okay, so 134 plus 68.7. Notice that it gives me 202.7 degrees. That exceeds 180. That means that just with these two angles, there's no way that I can form a third angle, okay, so that there's a second triangle. So that basically means because it's exceeded that, no second triangle exists. So there's only one triangle. So only one triangle can be formed in this particular scenario. Now let's figure out what that triangle is. Okay, so that basically means that we don't have to worry about a second triangle. We can proceed with that. So I already know what this guy is. Okay, so I already know all of these guys. All right, so this was 46 degrees. That means I can figure out what C is now. So C is just basically taking 180 minus the sum of these two triangles. So 68.7 plus 46. So I'm going to take 180 minus 68.7 and 46. And I got 65.3 degrees. So that's going to give me angle C. And then finally, to figure out what little c is, all I got to do is just use the law of sines again. Okay, so I'm going to use sine C over little c equals, and then I can just use whichever I want. So I'm just going to use B, sine B over little b. So I'm going to have sine C, which in this case is 65.3, divided by little c, which I don't know, equals sine B. Oops. So in this case, it's going to be, why is this not writing? Sine. So B, what was B? B was 68.7 divided by little b. And little b in this case was 25.4. Okay, so let me cross multiply. So you're going to get that C sine of 68.7 is equal to 25.4 sine of 65.3. And let's just divide 68.7. Okay, so then C is going to be approximately equal to, so let's plug that into our calculator. So we're going to have 25.4 sine of 65.3 divided by sine of 68.7, and that's going to give me 24.8. This is going to be, I think, what was the measurements? Inches. Okay, so you can see here that one triangle did exist, and you were able to solve the triangle itself. When two triangles exist, that means that you have to do double the work, okay? Because not only did I have to find this triangle, then you have to find out what the other triangle is. So in the next video, I'm going to show you how you can do that using the law of sines.